So in this video, we're going to be talking about graphing by hand, which is a skill that a lot of you have used, again, in past math classes. That's kind of the goal of Unit 1 here, is that we're reminding you of a lot of skills that'll help you in the rest of pre-calculus, one of which being graphing by hand. Now, as mentioned before, I know that graphing at times can be tedious, especially graphing by hand. But the reason we want to remind you about these particular skills is the video you just watched is about solutions, and we want you to be careful about noticing which points are truly solutions. So I'm going to write a note here to look for specific solutions, x comma y. Also, graphing by hand helps the practice with something that never goes away, order of operations. Okay. And it's also to remind you that if you're ever without a calculator, or you have a test without a calculator, how to graph by hand. So with that, remember that generally when you want to graph by hand, we have used tables, x comma y. Usually these are your input values, and these are your output values. Commonly, I'm known to usually do a little bit of negative, a little bit of positive, and always include 0 because it's the best thing to plug in for the order of ops. So I would say in general, -2, -1, 0, 1, 2 is what I usually start with. Speaking of that, let's go to the first example here. Graph the following equation by hand and discuss or describe any features about the graph. I want to focus just on graphing the equation by hand. We'll do the discussion together in a little bit. So I would like to, before you start, predict what this graph is going to look like. I notice first that my function is squared. If you're thinking to yourself, it's going to be a parabola, I agree with you. Now, is this parabola going to be facing upwards or facing down? Well, because of this negative in front, my parabola is going to be facing downwards. So I'm going to ask you to pause the video. I would like you to make an XY table. Pick whatever values you'd like. I'd suggest a little negative, little positive, and 0 in there. And I would like you to use the order of operations to get some points, plot them here, and your graph should look like an upside down parabola. So please pause the video now. All right, so a few things I want to point out here. If anybody followed my lead and did -2, -1, 0, 1, 2, and graphed it, you might have noticed that the graph does not yet look like a parabola, which means it's not centered around 0, which does cause a problem, but let's check your values first before we go into that. The reason I started and I suggested you start with -2 and -1 is because of the order of operations. Please make sure you are following the order of ops, especially right here. If you're thinking PEMDAS, exponents always come before multiplying by -1 in front. So if you square -2, you get a +4 and then multiply by -1. So you'd have -4 minus 12, -16 minus 1, so this should be -17. In the same way, if you square -1, that becomes a +1, and then you multiply by the negative in front. So we'd have -7 minus 1, or -8. So please be careful here and here with your order of operations. Let's check the rest of these to see if you did the same thing. When I plugged in 0, I got -1 out. When I plugged in 1, I got 4. When I plugged in 2, I got 7. What I did, though, was after I realized that after my prediction of the parabola, I didn't have a parabola yet, in blue, I just continued on and picked more possible solutions. And when I did that, when I plugged in 3, my answer was 8 out. When I plugged in 4, I got 7 again. And then I remembered and reminded myself that if I have a parabola, I'm going to have some symmetry. Whatever value happens here is going to happen over here. So I started to notice a pattern to save me time. 8 seemed to be a turning point because I got 7 here and here on either side. So without doing all the order of operations work, when I had 5 as my next number, I automatically said it had to be 4 to match the symmetry, and then the next one automatically had to be -1 to match the symmetry. So if I graphed all these remaining points, 3, 8, then if you take a look, the next value would be symmetric. The next value after that would be symmetric. The next value after that, again, would be symmetric, and so forth. And even though I didn't have this in my table, I'm going to predict that the next value would have to be here. So if I connected all those points, I had one value all the way down there. I do get a parabola that's upside down. Easier said than done to graph on this thing, that's for sure. So I'd have a parabola that's facing downwards. Okay. So the reason I picked this example is, let's say this was you on a test and you're not getting the value that you predict. Keep going in your table until you notice some symmetry for a parabola, and then everything will work out for you. Please also keep in mind the order of operations on this first part of the problem. Now let's talk about some characteristics of this parabola. So before we started, we said, first, I know this has to be a parabola in the first place because I have an x squared function. So that's something that's easy to predict. Secondly, because I knew that the x squared function was negative in front, I knew that it was facing downwards, or more specifically, it reflected over the x-axis, or flipped over the x-axis. That's another thing I can predict or guess before I use a table. Other characteristics of this parabola is a vertex. So let me go up here. It looks like this parabola has a vertex where it turns around at 3, 8. And that vertex also has to do with something, as you might recall, as the axis of symmetry. And that's the line that causes the symmetry or cuts the parabola in half. So another characteristic is the axis of symmetry. And the axis of symmetry is a vertical line. And notice it hits the x-axis at 3, so the equation of the axis of symmetry would be x equals 3. Other characteristics of this parabola is a y-intercept here at 0, -1. That yellow is not that great. Let me redo that. 0, -1 would be a y-intercept. And lastly, this parabola does have 2 x-intercepts. Now, my picture is not perfect, so we probably have to be a little bit more neat in order to say what the exact answers are. They're not exactly at 0 and 1, 2, 3, 4, 5, 6, so we can make a prediction. These points in purple you could call x-intercepts. You might remember that they're also called roots, or to go back to the last video, they're called solutions. Let me predict that this is maybe like 0.1. So one solution would be 0.1, 0, and the other one, let's do 6.2, 0. So when you're looking at a parabola, some of the main characteristics: x-intercepts, y-intercepts, axis of symmetry, vertex, and then predicting in general what the shape is going to do. Speaking of that, I want to give you a chance if you'd like to try other examples. So if you would like to try to graph these with a table, feel free. Y equals -2x plus 3. Y equals 2x cubed, same numbers on purpose. And then y equals x minus 3 with an absolute value. Now, before you go straight to the table, let's talk about quick predictions. This first graph is x to the first power. And whenever anything's to the first power, I know that it is linear or a line. This function is x cubed, so it is cubic. So this one is going to be some kind of line. This one is going to be some kind of cubic or snake. An absolute value, it's in the name. This is the memory trick I use. Absolute value should look like some kind of v. So with that, if you'd like to try these 3 examples, either on your notes packet or a separate piece of paper, please do so. and I will come back with all three with the table and the graph. So please pause now. All right, guys, so here's all my work, depending on which ones you tried. This first problem I did with the table first, and I did get a line, and it makes sense that my line is decreasing from left to right because it has a negative number in front or a negative slope. Some of you might have used a table. Others of you might have said, I know that this graph starts at the y-intercept of 3, and then I go down 2 over 1, down 2 over 1. Either way works for me. The second example is cubic. The reason I picked this is just to remind you again about the order of operations. So for this first example, if you cube -2 first, because it's raised to a power, then you would get -2 cubed, which is -8 times 2 is -16. -1 cubed is -1. -1 times 2 is -2, and you continue that idea. If you did that correctly, you would get a snake that is very stretched out, increasing from left to right, which is another good prediction. I know that because the lead coefficient is positive, so it will be increasing from left to right. Last but not least, for review from a previous video, let's talk about absolute value. Now you might notice that my table is much larger than the other ones because when I did my -2, -1, 0, 1, 2, it was not enough for the symmetry. Just to check your order of ops here, when you plug -2 in, make sure to combine inside the bars first before you take the bars off. So the absolute value of -2 minus 3 is the absolute value of -5. This is a distance from 0, so it would be a +5. And that pattern continues down. The absolute value of -1 minus 3 is the absolute value of -4. Absolute value of a negative number is a positive number because distance is always positive. So notice that all of my output values all the way down are always positive numbers. Also notice that here is probably the middle of my absolute value because I start getting symmetry on either side. So when I graphed it, I started with where I saw symmetry. These are just bonus points. I had an absolute value that was facing upwards. I knew it was absolute value because V in the name, and the absolute value is facing upwards because I have a positive number in front. Feel free to go back and rewatch any of this video. Feel free to pause the video anytime to copy any of this down that you'd like. These extra examples were just for you to help with other types of graphs. All right, guys, thank you for sticking with me again. I will see you at the next video.